Yeah, so assignment number 3. I want to start with the discussion of question number 3. If anybody has a doubt in question 1 and 2, please let me know. Otherwise, we'll start with the discussion of question number 3. So just go through question number 3 and try it out. So in question 3, a vector is given to you in geometrical form, and you have to find the vector in component form. Or you have to express this given vector in component form. So just tell me what the correct answer should be for this. So this is the information that is given to us. So we have to express the vector E in component form. So can you quickly work this out and tell me which option is correct? Yes, Anmol, that is correct. Yes, Rimjim, that is correct. Correct, Prince. Good. So what we have to do here is you can redraw the vector E which is given from the origin so that there is more clarity about it. So you can see that the vector is like this, where this angle is 30. That means the angle it is making with the x-axis is 150. So magnitude of A is 10 and the angle is 150 degrees. Okay. So the x component will become, so 10 cos 150 degrees. Now cos 150 is the same as minus cos 30. That is minus root 3 by 2. And sine 150 is the same thing as sine 30 or half. So this will become minus 5 root 3. And this will become 5. So the vector E will be minus 5 root 3 I cap plus 5 j cap, which is option C. So good, many of you have got this without any difficulty, so that's good. Others, you can please note down the solution. Okay, and those who have finished this, you can move on to, I'll tell you. So this was question 3. Question 4. Yes, Aman, I will come to question 8, 9 also. Thanks. So if you can tell me the method, or you can tell me the answer of question number 4 next. Try that out, please. Okay, so the magnitudes of A and B you have found out, and from that, how can you say it's a right angled triangle? Aman, the answer you're giving is yeah, Anmol, your answer is correct. Good. Okay. Okay, now I'll give you a simple idea of solving this question. What you can do is, so see, the vectors are given to us as these 12 I cap, 16 j cap. And the vector B is given to us as minus 8 I cap plus 6 j cap, is it? Yeah. So to find the angle between them, what we can do is we can simply understand that this vector is of magnitude 20 and is at theta equal to how much? Tan inverse 16 by 12. So that is 53 degrees with respect to x-axis. Whereas this vector has a magnitude of 10, but more importantly, the angle it is making is how much? It is tan inverse of 3 by 4, okay, but with a minus sign. So it's in which quadrant? It's in second quadrant. So it is 180 minus 37, okay, so that is 143 degrees with respect to the x-axis. Or you will get this with more clarity if you draw these vectors. If you draw these vectors, you can understand that the vector E is in the first quadrant because it has a positive x component and a positive y component. You can see that for this tan theta is y upon x, okay, so 4 by 3. So that means theta is 53 degrees. So for this vector E, this angle with respect to the x-axis is how much? It is 53 degrees. But for the vector B, what is happening is that it has a negative x component and a positive y component. So the vector B, इसका x component कितना है? -8 and y component कितना है? +6. Okay. So this angle is becoming, so what is happening? Tan theta is equal to -6 by 8 or -3 by 4, and it's in quadrant 2. In second quadrant. So that means theta is going to be 180 minus 37 or 143 degrees. Okay, because in second quadrant you know that tan theta is minus of tan 180 minus theta, that is -3 by 4. Okay. So you know that 180 minus theta is 37. Okay. So therefore theta is 143. So this angle is becoming 143. Okay. So now we can see that the angle between these two, this one, is how much? It is 143 minus 53 or 90 degrees. Okay. So the correct answer here will become 90 degrees. Okay, so please make a note of this if this is not clear so far. Hence, that is coming from the components. No? Magnitude of a vector is root of x square plus y square. Yeah. So Arvinda, how we came to the conclusion that the second vector b is in the second quadrant. Okay. You can see b is having a negative x component and a positive y component. So that's how I know. So that's how I know that when I draw this vector, इसका x component कैसा है? Negative है. So x component of b is like this. It is -8. Whereas y component of b is like this. It is +6. So that is how I know that the vector b is like this. Okay, so that's how I know that it has to be in the second one. Okay, Arvind, this is clear. That was the important point in this question, which is why I'm discussing it actually. Okay. So you have to see the algebraic sign of the components. A के दोनों component positive है, so it's in first quadrant. Okay. B का x component is negative, y component is positive, so it is lying in the second quadrant. Okay, so I think this is clear to all of you. Let's move on now. Okay, let's move on to 6th and 7th question. They're based on the same data, so just go through it and try it out. So it is given to us that the sum of two vectors a plus b is 10i cap, and the difference of two vectors is 10 root 3 j cap. This information is given. Now from this, we have to find out magnitude of a and magnitude of b. That is 6th and 7th question is magnitude of b. So anybody got the answer for this? Okay, so I'll give you a hint on how to try out this question. See. Yes, that's correct, Prince. Vectors A and B are unknown. Okay, but you have two equations. Yes, Aman, that's correct. So solve the two equations given to find out A and B. Okay. So this is equation 1 and this is equation 2. You can do the operation equation 1 plus 2 and that will give you the vector A, and then from that you can find out the magnitude of the vector A. And similarly, if you do the operation 1 minus 2, you will be able to find out what vector B is, and from that you will be able to find out the magnitude of vector B. Okay, so you have A plus B is equal to 10 I cap, and you have A minus B is equal to 10 root 3 j cap. Equation 1, equation 2. So if we just add these two equations, you can see here you will have 2A is equal to 10 I cap plus 10 root 3 j cap. Okay. So vector E is 5 I cap plus 5 root 3 j cap. So magnitude of vector E becomes square root of 25 plus 75, so that is 10. Yeah, Dushant, it's correct. Whereas if you subtract the two equations, equation 1 minus 2, you will get 2B is equal to 10 I cap minus 10 root 3 j cap. So you'll get vector B as 5 I cap minus 5 root 3 j cap. But that again means its magnitude is the same. It's 10. Because okay. So these are the magnitudes of A. Next, we'll come to question number 8. So go through it carefully. So question 8 is a slightly more tricky type of question. So I'll explain what you can do in the question. You can try it out yourself also. So question 8 gives us some information that, first of all, magnitude of the vector A is given to you as 5. Okay. Then it is given to you that the vector C is E plus 2 times some vector B, such that C is perpendicular to E. Okay. So that is one information given to you. Whereas there is some more information given about a vector D that is equal to A and B sum, or A plus B, and it is given to us that the magnitude of the vector D is equal to 5. Okay. So this information is given to us. So in fact, question 8, 9 and 10, they are all based on the same information. So we'll solve these. So we have to find out the magnitude of the vector C. We have to find the magnitude of the vector B, that is question 9. And we have to find out the angle between A and B. That is question 10. Okay. So here's a hint of what we can do. If you want to solve this question geometrically, okay, you can do it by component algebra also, and I'll come to that. But geometrically, if you want to solve it, make a vector triangle for this, okay, and write equations for that triangle, and make a vector triangle for this one also. Okay. Now, when you make a vector triangle for this one, this is perpendicular, so you can make use of Pythagoras theorem or trigonometry. Okay. Whereas this one is not a right angle triangle, so make use of triangle law, okay, to write some equations, and when you solve those equations, you will be able to get the unknown quantities. Okay. So you can try it by what I'm saying over here. Represent this information given over here as a vector triangle first, okay? And since this is perpendicular, so it's a right angle triangle, so you can use Pythagoras theorem and trigonometry's combination. Similarly, represent this information given as a vector triangle and use triangle law in that. Okay. Yeah, man, I have seen what you're trying to do. That's okay, but you know, rather than visualize B as a chord and all that, we can get it more simply by just following the instructions and drawing these triangles. Okay, so let's start by drawing the vector triangle for the operation C is equal to E plus 2B. So suppose we're looking at this, यहाँ पे हमको क्या information दिया हुआ है, C is perpendicular to E, okay, and it is also given that magnitude of A is 5 units. Okay, so this particular operation will look like this. This is the vector E. The vector 2B has to be something like this, so that C becomes perpendicular to it. So A ऐसा है 5 units का, 2B ऐसा है, इसका magnitude नहीं पता. This angle is not known. Okay, but at the same time we know that C, which is the sum of these two, C's magnitude is also unknown, but we know this angle is 90. Okay. So from this vector triangle, what is the equation we'll get? Okay, that's one thing. That's the first equation we'll get. And the other equation we'll get is that this angle is 180 minus theta. So cos of 180 minus theta is E by 2B. Or minus cos theta is 5 by 2. Or cos theta this magnitude is 2B, which is unknown. This magnitude is C. This magnitude is E, which is 5. This is a right angle triangle. So these are my equations 1 and 2. But as you can see, we don't have enough equations right now because we have 3 unknowns. Theta is unknown, B is unknown, and C is unknown. So we need more equations. So that is where the second triangle will come in. Now similarly, if we draw the second triangle, what is the information we are getting from that? B is equal to A plus B, where magnitude of D is 5. Magnitude of A was also 5. So that triangle in comparison will now look like this. Compared to the previous triangle, A is the same. It is a vector of magnitude 5. But there we had 2B. Here we have only B. So in comparison, B will have to look like this. Okay. Its magnitude is unknown. Okay. And the sum of these two is the vector D, जिसका magnitude मुझे दिया हुआ है. कितना है? It is 5 also. Okay. And this angle theta between A and B is the same. This angle theta. Okay. So here we can use triangle rule. So we can see that magnitude of the vector D is magnitude of A plus B is the root of A square plus B square plus 2AB cos theta. So So now substitute this information given. Okay, so we can see that 5 is equal to square root of 25 plus b square plus, okay, 10b cos theta. Or if we square both the sides, we get 25 is equal to 25 plus b square plus 10b cos theta. So we can say that b square plus 10b cos theta is equal to 0. So obviously b plus 10 cos theta is equal to 0. So this becomes our third equation. Now the next thing you have to do is solve these three equations. Two from the triangle given above and one this one. So solving equation 1, 2 and 3, you will be able to get the required answer. Okay, so next step, what you can do is you can just substitute the information given in equation 2 in equation 3. Okay. So here substitute cos theta equal to minus 5 by 2b. So you get b plus 10 into minus 5 by 2b is equal to 0. Yes. So we will get b is equal to 25 by b square, sorry, by b. That means b square is equal to 25. Now that means that b being the mod of a vector, it cannot be a negative quantity, so it will be 5. So magnitude of b is known. So put this back in this equation. So therefore we have cos theta is equal to minus 5 upon 2 into 5. So minus half. Now cos theta is negative, that means theta is in second quadrant. Okay. So since cos 60 is half, therefore cos 120 is minus half. So therefore in this case cos theta is equal to minus half implies that theta becomes 120 degrees. That becomes your second thing answer. Okay. And then substitute that back in that equation earlier, that equation of C. So C will become equation 1. Okay. C will become square root of 4b square minus 25. So this is from equation 1. So substitute this here. So this will become 100 minus 25. So that's 5 root 3. So magnitude of C will become 5. So those are the 3 parts. Yeah, how we know theta is the same in both the cases? We know because see, which are the 2 vectors we are talking about? We are talking about the vectors B and the vector 2B. So both are like this, no? They are parallel vectors now. So this is the vector B, this is the vector 2B. So they are parallel vectors. So whatever angle they are making is the same. That's the same direction as the vector B. Okay. It has double the magnitude, but the same direction. Therefore, 2B makes the same angle theta with respect to the vector E as vector B. Okay. So if E was a vector, that was another important thing to catch in the question. Vector E अगर ऐसा है, that was a connection between the 2 vector triangles. That exterior angle is the same. The angle between the vectors E and B is the same as the angle between the vectors E and 2B. Okay, so quite a manipulative question, as you can see. Okay. Now I'll also leave you with a hint of how to do this by component algebra. Okay, you can also do this question by component algebra. So I'll just give you the hint to save time, and you can try it out yourself later. Okay, but first of all, I'm just leaving you with this once more. Just go through it in detail. Let me know if there's any doubt. Okay, so this question can also be done. But first of all, any doubt in this? Okay, yes. Now you can do this question this way using component algebra. Magnitude of vector is given to us as 5. So let us assume that vector E is 5 I cap. Okay, that is x-axis is taken along vector E. And accordingly, the vector B is some bx I cap plus by j. Therefore, the vector C, which is E plus 2B, will become equal to 5 I cap plus 2 times bx I cap plus by j. Or the vector C would be 5 plus 2bx I cap plus 2b by j. This is my equation. Okay. Now, given that C is perpendicular to P, okay, therefore, since E is along x-axis, it implies that C should be along the y-axis. So that means C's x component should be 0 and C's y component should be constant. So therefore, from equation 1, you can see that we get 5 plus 2bx should be 0. That becomes your second equation. Let's go through this and see if this is clear to you. Now, similarly, there's some information about D given to you. So that will also give us an. The next thing is given to us that D is equal to E plus B. And magnitude of D is also 5. So that means D is equal to 5 I cap plus bx I cap plus by j cap. That means the vector D is 5 plus bx I cap plus by j cap. That means the magnitude of this should be equal to how much? 5. So this becomes our so now again, from equation 1, 2, and 3, you will be able to get dx and dy. So basically, what you do is you solve equation 2 and 3. Solve equation 2 and 3 to get dx and dy. So from that, you will get mod of d and you will get mod of c. And you will get theta, the angle between them. Is the method clear, people? Okay, so note this down and come to question number 10. Oh, sorry, 10 is done. Question 11 to 14, which is based on the same diagram. So I'm leaving the solving of this for you to do yourself. Try it out and let me know if there's any difficulty later. Okay. Now we come to question 11 to 14, for which you are given this diagram. In the xy plane, 3 vectors are drawn for us geometrically. Okay. Vector A is like this. This angle is 60 and this magnitude is 10. vector B is symmetrical like this, this 10 and this angle is 60 again, and vector C just 10 along the x-axis, drawn like this. It's parallel to the x-axis and its magnitude is 10. So now you have to work out all these different things here. So for example, in 11th question, you have to work out what is A plus B and what is E minus B, so that you can select the correct option. Then similarly for 12th question, you have to work out magnitude of E plus B plus C. Similarly for 13th question, it's very similar. You have to basically check the options. So these are all about solving these vectors. So one way of doing this is that convert these to component form. Convert to component notation. I'm just showing you that vector E, for example, in component notation will become 5 I cap plus 5 3 j cap. So similarly, you write vector B and vector C, and then you work out each of this. So just try this out, people. Yes, Dushan, that is correct. Good. So you can see from this diagram that if you write out all the vectors in component form, just one minute, let's make some space here. So as we convert all the vectors to component form, our vector is 5 I cap plus 5 root 3 j cap. Our vector B will become minus 5 I cap plus 5 root 3 j cap, and our vector C will be equal to 10. So therefore you can see that E plus B, just add these two, is becoming 10 root 3 j cap, whereas E minus B is 10 I cap. That is why you can see that in question 11, the correct options are becoming which ones? Question 11, E plus B is a vector that is pointing along y-axis. So option A is correct. Then option B is wrong. Option B is also correct. So you have to select the incorrect option, remember. So C is becoming the incorrect option. And D is also correct. So ultimately you have to select this option. This is the incorrect one. So the answer to question 11 becomes that C is the incorrect option. And similarly, question 12, you have to find A plus B plus C. So A plus B is this much and C was this much. So it is 10 I cap plus 10 root 3. So you can see that magnitude of A plus B plus C is becoming square root of this. So that, as you know, will become 20. So question 12 will have B as the correct answer. Now, like that, question 13 is now a little bit tricky. Question 13, we have to see each of the options. So it is saying which of these is a null vector. So E minus B plus C अगर करें कितना आएगा? So you can see that E minus B was how much? It was 10 I cap. And C is how much? 10 I cap. You can see that E minus B plus C is becoming how much? It is becoming 20 I cap. So that option is not correct. It's not a null vector. Then similarly, you look at B minus A plus C. Look at this. So you can see that E minus B is 10 I cap. Therefore, B minus C is equal to, B minus A is minus 10 I cap. Therefore, so that is a null. So that becomes the correct option. So that is your question number 13. And similarly, question number 14 is about angle. So in question 14, you can see that E plus B plus C from earlier we had seen. This was 10 I cap plus 10 root 3 cap. So it is at theta equal to tan inverse root 3, or that is 60 degrees with respect to x-axis. Okay, so these are the assignment problems. Arvinda, how we wrote this is by component concept. By resolution of a vector into components. If you go back to your first diagram, you can see that, for example, the vector E. So for vector E, you can see that the magnitude is 10 and the angle with the x-axis is 60 degrees. So x component will become 5. Y component will become 5. Similarly, for the vector B, you can see that the magnitude of the vector is 10, but the angle with respect to the x-axis is actually this one angle, it's 120 degrees. So dx, which will be cos 120, which is minus half, it will become minus 5. dy is sine 120, which is plus root 3 by 2 into 10, so it will become 5. And C directly you can see is along the x-axis. So the main thing was this one, converting to component notation. This is the method. Okay, so Arvinda, I hope this is clear now. Oh. Okay, so that brings us to a conclusion of this assignment. Question number 15 is very easy. You have to do it yourself. So please complete any remaining questions and discuss with me if you have any doubts. Now, next thing we'll move on to is again the three-dimensional component algebra. So coming back to components in 3 dimensions. Okay. So we had seen last time that we have a vector with 3 components like this. Then the magnitude of that vector becomes this. So let us start with some applications of this. So for example, S is a displacement which is the resultant sum of three individual displacements made in succession, wherein, let's say, S1 was the displacement of, let us say, 10 kilometers towards east. S2 is the displacement of 30 root 2 kilometers towards southeast, that is 45 degrees south of east. And S3 is the displacement of, let's say, let's make these in meters instead of kilometers. It is 120 meters vertically upwards. The first thing is that taking the XY plane as a horizontal plane such that I cap is towards east and J cap towards north, and the Z axis being vertical. Express S1, S2, and S3 in component form. Secondly, given S is equal to the sum of these three displacements, one after the other, in succession, find the magnitude of the resultant displacement. Let's try out this question before. So from the language of the question, you have to understand what this is looking geometrically like, and you have to write the vectors S1, S2, and S3 in terms of I cap, J cap, and K cap from the information given, and also from the instructions given, that how you have to select your axis. Yeah, Anmol, your answer is correct. Very good. Dushan, vertically upward means opposite to gravity. So it is not north direction. Okay, north lies in a horizontal plane. So this will be something like this, that let me explain the difference between vertically upwards and something in a horizontal plane. So suppose this is a horizontal plane. This whole thing, it's a horizontal surface. Yeah, Akshat, correct. In which this is the north-south direction. And this is the east-west direction. This is north. So which is the vertical direction now in this? The vertical direction becomes this one. This is your vertically after that. This is your vertical axis, which is perpendicular to both of these axes. Gravity is this. So here what we'll do is we will be taking this as our x-axis, this as a y-axis, and this one becomes our z-axis. So now if we see this from front up, if we view it like this, yes, Aman, it is correct now. You see that your x-axis towards east like this, and y-axis towards north like this. So your first displacement S1 will be 10 meters towards east. So S1 will become 10 I cap in meters. Your second displacement, which is 30 root 2, will become like this. (45°), oh sorry, south, my mistake. So that will become like this. So this will be my S2. So in component form, S2 can be written like this. Now in this diagram now, where is my S3 going to lie? S3 is going to be vertically upward. So S2 was like this. S1 was along the x-axis. But S3 कहाँ होने वाला है? It will be vertically upwards. This is towards southeast. This is towards east. So now my net displacement, which is the sum of S1 plus S2 plus S3, that is becoming 10 I cap plus 30 I cap minus 30 J cap plus 120. It's becoming 40 I cap minus 30 J cap plus 120. That is the resultant displacement. The second part of it. So the magnitude of the resultant displacement will become root of x component square plus y component square plus z component square. So 130 meters, the net displacement. Okay, so this is the application of the three-dimensional vector algebra concept. Okay, so hope this is clear to all of you. Yeah, friends, on the horizontal plane, see, this vector S1 is 10 meters towards the east. So it becomes 10 meters along my x-axis. So it's 10 I cap. Whereas this one is 30 root 2 towards S2 is 30 root 2 towards southeast. Okay. So you can see that it's 45 degrees. Okay. So S2 का जो x component है वो कितना हो जाएगा? It will become 30 root 2 cos 45. So that will be 30. But S2 का जो y component है वो कितना हो जाएगा? 30 minus of 30 root 2 sin 45. This one, this component, this component, this will become minus. Is it clear now, friends? So that's how this vector In component form is becoming this. Okay, good. Yes, so the answer is 130 meters for the second one. Magnitude of the resultant displacement is 1. Okay. Now let us see another type of related question. If a particle moves from point P, which is given by, let us say, 1, 0, 1 to a point P, it is, let's say, 4, 4, comma 5. But first of all, find its displacement S in component form and the magnitude of the displacement. Secondly, if it moved from A to B at uniform velocity of magnitude 8 meters per second, then find its velocity vector in component. So this is a question. You take note of the question and explain how to work it out. Yes, that is correct. Okay. So basically, see what is happening is that if a particle is going from a point E, which has some coordinates x1, y1, z1, let's say, to a point B, which has a coordinates x2, y2, z2. So उसका displacement vector जो है वो ये वाला वेक्टर में हो जाएगा. Such that now you can see that that displacement vector in component form will be given as x2 minus x1. That is the change in the x coordinate, that's the x component, plus y2 minus y1, that is the y component of displacement, plus z2 minus z1, that is the z component of displacement. So in this particular case, that will become 3i cap plus 4j cap plus 4k cap equals. Because this point was so therefore now magnitude of the displacement you can directly see. Or whatever unit is given. Now next thing we have to understand the velocity vector. So the velocity vector will be a vector pointing in the same direction, but of magnitude how much? Eight meters per second. So these were given in meters. So this is given in meters per second. Aman, your answer for magnitude of S is right, but velocity vector will not be like that. The velocity vector will be slightly different. So to find the velocity vector, to understand that the velocity vector is along the displacement vector. That is B and S have same direction. So that means that the unit vector of velocity should be equal to the unit vector of displacement, where this concept such that E cap is the unit vector which is along the vector. So use this concept over here and try to come up with the velocity vector. Okay, we will. So hope this idea is clear here. So from here you can see that the vector S was this thing. It was 3 I cap plus 4j cap plus 4k cap. So a unit vector along the S, or what we call S is unit vector. Therefore S cap will become 3 I cap plus 4j cap plus 4k cap divided by its own magnitude. So that is so 3 I cap plus 4j cap plus 4k cap divided by square root of 41. So this is the unit vector along the displacement, or you can say it is along the line EP. So now velocity should become what? Velocity should become its magnitude into unit vector. So magnitude of velocity is 8 meters per second. That was given to us. And because the velocity vector is also along the displacement vector, or along the line EB. So my velocity as a vector now will become 8 meters per second multiplied by that vector. So this is a kinematics sort of application of vector. So 8 by root 41 into 3 I cap plus 4j cap plus 4k cap. This we can express as the velocity vector in meters per second. That becomes the final answer. Okay, people. So this is the concept of unit vector. How we can make use of unit vector when two vectors are parallel to each other. So if vector E is parallel to vector B, parallel vectors E and B will always be such that E cap is equal to B cap, or vector E divided by mod A will be equal to vector B divided by mod A. So this is the concept of parallel vectors that we used over here for displacement and velocity. They are parallel to each other, or they are along the same line. So their unit vector should be the same. Okay, people. So hope this is clear. So with this last concept of parallel vectors having the same unit vectors, we come to a conclusion of today's session. So I'll be sending you another practice worksheet, worksheet number 4, which is based on all these concepts, including the 3-dimensional vector algebra. Okay. So attempt these questions before the next lecture, and also complete anything remaining in the first 3 worksheets, so that you're up to date by the time we come to the next lecture. Because then we will start the next part of vectors after that, which is to do with the products. So there are 2 types of products of vectors: scalar product and cross product. So we'll be discussing about those things next. Okay. So wish you all the best, and take care. Okay. Be safe. So that's it for today's lesson.